In this video, we're going to look specifically at the way we can calculate areas based on previous knowledge. The reason we want to look at this is because, starting with our physics examples, if we want to figure out how far we've traveled in a scenario and all we have is a velocity, the connection between those two properties, distance traveled and velocity, is going to be the area underneath the graph of the velocity. So, we've now identified a more general problem, calculating the area underneath a graph. And we can do this already for fairly simple examples. The graph of y equals x plus 1 is this line here, and if we're asked to calculate the area defined by that graph on a certain interval, notice that's a required input to this problem, on what interval do we want to calculate the area? Well, we can do that by looking at that area and recognizing, hey, that's a triangle. So that area would be the area of a triangle, and that triangle area is 1/2 base times height. And with the 1/2 base times height, we just note the base is 2 long, and the height is from 0 to 2 as well. Nice 45-degree triangle. And so our total area would be 4/2, or 2 square units. Perfect. So if we have a nice simple graph, we can find the area. Let's see where else we can go with this. What if we try to calculate the area between the x-axis and the graph of y equals the square root of 1 minus x squared, again on a specified interval, -1 to 1 in the x's? Well, that looks more complicated on the face of it until we recognize that y equals the square root of 1 minus x squared is equivalent to y squared is 1 minus x squared, or x squared plus y squared equals 1, which is a circle. And more specifically, a circle with radius 1. Well, if that's the case, looking at a diagram now, we can interpret this area here as half the circle area. And the circle is radius 1, careful of the radius diameter difference, but if the radius is 1, the circle area overall would be pi r squared, radius 1 squared, and so we'd end up with pi over 2 square units. Perfect. Now we hit the fly in the ointment. Think of other shapes that you know right now for which you can actually calculate the exact area. We'll give you a moment to think about that, and then we'll see what common answers are. All right, so most people, circles, absolutely. Parts of circles, quarters of circles, fractions of circles, rectangles, triangles, and that's usually about it. Everything else that most people know, trapezoids, are made up of rectangles, triangles, or circles. Parallelograms, you might have a formula for that. Well, that's just rectangles and triangles put together. And you realize very quickly, this list is short. The things we can actually calculate the area for is not a big set. So going back to our challenge of looking at how far we've traveled given a velocity graph, we are going to need some new tools because this calculation is all about areas, and we do not have a lot of tools for areas, as it turns out. That's what we're going to spend our time exploring moving forward.